Hello everyone. Welcome to the solution of LeetCode problem 2001 named number of pairs of interchangeable rectangles. Here we are given an n rectangles represents by a two-dimensional integer array where rectangle of I is equal to width and height denotes the width and height of the corresponding rectangle. Now two rectangles I and J are considered interchangeable if they have the same width to height ratio. That means more formally, two rectangles are interchangeable if the width by height ratio of both of them is equal. That means width divided by height of the first rectangle is equal to the width divided by height of the second rectangle. So now we have to return the number of pairs of interchangeable rectangles in the given input. Suppose in the first example, we are given 4 rectangles. The first one is 4, 8, second one is 3, 6, the third one is 10, 20, and the last one is 15 and 30. So here we can see that the first rectangle is interchangeable with the second rectangle because the width to height ratio is equal. That means 4 by 8 is equal to 3 by 6, which is 1 by 2 is equal to 1 by 2. Similarly, the first rectangle is interchangeable with this third rectangle because their width to height ratio is same and so on. So here we can see that for this example 1, the output is 6. That means there are 6 possible interchangeable pairs of rectangles. So now, I hope you understood the problem statement. Now let's move on to the algorithm. Now, for the sake of simplicity, we have taken the first example, which has 4 rectangle, which is 4, 8, 3, 6, 10, 20, and 15, 30. So, for the first rectangle, the width by height ratio will be 4 divided by 8, which is 1 by 2. So, we have to add 1 by 2 here. Similarly, for the second rectangle, the width by height ratio is 1 by 2. For this third rectangle, the width by height ratio is 1 by 2. And for this fourth rectangle, the width by height ratio is 1 by 2. Now, there are 6 possible interchangeable rectangles. One pair is this, another pair is this, another pair is this. And there are one pair is this, another pair is this. And finally, another pair is this. So we can see that there are in total 6 possible rectangles which are interchangeable. Now, how can we solve this problem? By using some of the standard algorithm. Here, we should use the map data structure to solve this problem. Now, what is the intuition? The intuition is as we have to determine the number of interchangeable rectangles by considering the ratio. So, how or what we can do if somehow we can store the ratio into the map, and for each of the entry, we will check whether the corresponding ratio already presented in the map or not. If the corresponding ratio is already presented in the map, that means we can form one possible interchangeable rectangle here. Suppose currently we have to iterate each of the element from left to right. But suppose currently we are at this first index, which is 4 by 8. Now, the ratio of 4 and 8 will be 1 by 2. So here, we will use one map here, as we all know that map stores the value in the key value pair order. The first entry of the map is key and the second entry of the map is value. So here, the first entry is 1 by 2. So now, as the aspect ratio or the ratio is 1 by 2, we will check whether 1 by 2 currently is presented in the map or not. Initially, 1 by 2 is not presented in the map, so the answer will be 0. Now we have to store 1 by 2 as the one of the entry of the map. So here we have to add the frequency 1 because we have found 1 by 2 first time. Now we are at this position. Here 3, 6, their ratio will be 1 by 2 once more. So now we will check whether 1 by 2 is presented on the map or not. Yes, 1 by 2 is presented on the map and the corresponding value is 1. That means by using this 3, 6, we can make one possible interchangeable pairs, which is this. So now we can make one possible pair, so we have to add 1 to the answer. Now we have to upgrade the frequency of 1 by 2 from 1 to 2 because there are 2 entries of the ratio of half. Now we are currently at this position, which has the element 10 and 20. So their ratio will be half again. So we will check whether half is presented on the map or not. Yes, half is already presented on the map. So by using this third entry, how many interchangeable rectangle we can make? We can make 2 of the interchangeable rectangle till now. One is this and another is this. So we have to add 2 here, which is the frequency of corresponding map. Now we are at this position, which has the element 15 and 30. So here the ratio is half once more. But before that, in the previous iteration, we have to upgrade the value of the frequency from 2 to 3. Now we are at this last positions, 15 and 30. So here the ratio will be 1 by 2 again. So now we can see that there are 3 entries of the rectangle which has the aspect ratio is half. So we can conclude that we can make 3 of the interchangeable rectangle by using this 15 and 30 rectangle. So here we have to add the value 3 with the corresponding answer. Here the 3 rectangles are, first one is this, second one is this, and the third one is this. So here there are 3 possible rectangles. Now finally we have to upgrade the frequency of the half from 3 to 4. And as we have completed the iteration till now, so the total interchangeable rectangle will be 0 plus 1 plus 2 plus 3, which is 6. So 6 is the corresponding output for this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. We are given a function named interchangeable rectangles, which has a vector of rectangles, which has the dimension of each of the rectangle. Now, we are using one variable result to store the answer, and we are using map. The key of the map is the double and the value is integer. The key is store the ratio. As we are using double, that means we will store 15 digit after the period or after the dot sign, which will foolproof the calculation. So here the ratio will be stored in the double format. Now we have to iterate each of the element of the rectangle array and we have to find the ratio. So here the ratio will also be double and the ratio will be rectangle 0 divided by rectangle of 1. Now we have to check whether this ratio is currently presented in the map or not. If it is, that means we have to add the corresponding frequency of the map to the result. After that, we have to increase the frequency of the corresponding ratio. Finally, we have to return the result. I hope you understood the code. Now let's move on to the time and space complexity analysis. In this program, the time complexity is big O of n because we have to iterate each of the element of the rectangle, and the space complexity is big O of n also because we are using extra memory map which stores the ratio. That's why the space complexity is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.